for problem 19, we're going to use a combination of rules here. So in 19, we've got this fraction. We've got 4 squared to the 6th over 4 to the 10th. Now in the numerator, I've got a power to a power, right? So I know what to do here with these exponents. I'm going to multiply them. So this is going to become 4 to the 2 times 6 over 4 to the 10. Right? Remember, we multiply these. If you're raising a power to a power in our order of operations, right below power is multiplication. So we multiply. So we now have 4 to the 12 over 4 to the 10. And now we're going to subtract, right? We have a division. So 4 to the 12 minus 10, right? You subtract the top exponent minus the bottom. So we get 4 squared, we get 16. In number 20, now look at 20 here. We got a multiplication, and all the bases are a's. So we're going to write the base and just add the exponents, right? In a multiplication, the operation right below multiplication is addition. So we're going to write that base, and then we're going to add the exponents. Negative 3 plus 5 plus negative 7. So I'll have a to the, well, let's see what we get here. Negative 3 plus 5 is 2, and then 2 minus 7, negative 5. And then we're going to write this so only positive exponents appear. So I'm going to drop this base down into the denominator and change the sign of the exponent. 1 over a to the positive 5. Now in 21, this is one of those problems where there are several ways to do it. I'm just going to pick one way. You get 4x, that quantity is negative 2, 3x to the negative 3. What I'm going to do here is I'm going to move this one up and this one down, move those bases, and then do so by changing the sign of the exponents. So that will give us this fraction now. 3x to the positive 3 on top, and 4x to the positive 2 on the bottom. Now I can distribute this 3 into each factor and the 2 into each factor. Right, I've got something to a power, and that something is a multiplication. So I can distribute over that multiplication. So this will give us 3 cubed x cubed, and in the denominator, 4 squared x squared. Let's bring it up here. So now 3 cubed, 3 times 3 times 3 is 27, x cubed, over 4 squared is 16x squared. And now look at these x's. Let's just do this. Do it by counting. What have you got here? Isn't it really 3 x's? And down here you've got 2 x's being multiplied. So what I'm thinking is that I've got this. Here's what I'm thinking. I've got 27 and then x, x, x. In the bottom I've got 16 and x, x. Now, if I'm just counting those, these 2 x's here will cancel with 2 there, leaving 1. But that's also the quotient rule, right? I'm just subtracting. 3 minus 2 is a 1. So we are left with 27x over 16. Now in 22, again, there's a couple ways to do this. We have a to the negative 4, b to the positive 6, all to the negative 3. Now I could take this base here and drop into denominator and change the sign of that exponent. Or I could just, because there's multiplication in here, just distribute that exponent. And when you raise powers to powers, you multiply those exponents. So we're going to get a to the, now, negative 4 times negative 3 is positive 12. B to the positive 6 times negative 3 is negative 18. And then I want to write my result with positive exponents only, so I can get rid of that negative exponent if I drop the base into the denominator. So this will give us a to the 12 over b to the positive 18.